Hi, and this is section 10.3. We're going to learn how to solve quadratic equations by a different method today. We're going to learn how to solve them by graphing. All right. We spent chapter 9. We learned how to solve quadratics by factoring. And let's show an example of that. Let's take x squared minus 6x plus 8. And we could factor this equation to solve it. Remember, we would think about, okay, this is a trinomial, and it has a lead coefficient of 1, and what times what's 8, and adds up to -6, and you'd come up with -2 and -4, and you'd factor it. And the equation now would be x minus 2 times x minus 4, and since we're multiplying, one of these have to be 0. Well, for this to be 0, x would have to be 2, and for this binomial to be 0, x would be 4. And you just solved the equation. You just found out that the solutions were 2 and 4. We're going to learn how we can solve an equation like this by graphing, and you may use your TI-83 plus calculator to do this. All right, so this is very rare that you hear me say this. This is probably going to be the first question on my audit tomorrow. You don't have to do any work to solve these when you graph them, because you can use your calculator to do the graphing for you. So again, you guys have worked with me now for, what, a good 7 months and been in my class for 7 months, and rarely do I say, well, you can just get the answer by using your calculator and you don't have to show any work. This is one of those rare times. You don't have to show any work. You can just use your calculator and produce an answer without work. All right? So it's kind of neat to have that happen for a change. So how do we do this? Well, first of all, let's actually solve this very equation. Let's solve this using the graphing method. So what you might want to do for a minute is pause the video, get your TI-83 calculator out, and you might want to pause the video from time to time. I would highly encourage you to type in what you see on these screens so you can actually see it on your calculator. Don't just flip through the video, all right? Put it in your calculator. First of all, take that equation and type it in your calculator using the y equals key. And you can see an image of that here. I took y equals, I hit the y equals button, and I typed in x squared minus 6x plus 8. I did that first. Then I'm going to hit the graph key, and I'm actually going to take a look at the graph. And the graph, as you know, we've been sketching quadratic graphs through the beginning of chapter 10, and you know that any second-degree graph is going to give you a parabola. What we're looking for on this parabola is, where does the parabola cross the x-axis? And you notice in this picture, the parabola crosses the x-axis in 2 places. I circled them. Maybe I can do that again, or highlight this in red. You can see here, it looks like it's crossing in 2 places, maybe here and here. All right? It looks to me, and let me erase, it looks to me, just so you can see this better, and you should put this in your calculator and do it, it looks like it's crossing at the point x equals 2, and it looks like it's crossing at the point x equals 4. That's what it looks like. Now, we already know that that is indeed the correct answer, because we already figured it out in our last slide. Remember, the solution to this problem should be right here. It should be 2 and 4. Okay, so when you're graphing this, it looks like the solution's 2 and 4. We can quickly check that on our table. So we can now go ahead, hit the second button, and table. And you can look at a table, and do you notice on your table, it will tell you when you plug in 2 for x, y must be 0, and when you plug in 4 for x, y must be 0. So 2 and 4 are the values for x that create 0 for y. Those are the solutions, just like when we factored, we got 2 and 4. Those are the points that are intersecting the x-axis. Very simple to do it that way. Look at the bottom right now of page 644 in your book. You'll see 3 pictures in a key concept box. You must know these 3 situations, okay? The first situation would be 2 solutions. If you see a parabola and it's intersecting the x-axis in 2 places, that's when you have 2 solutions, all right? That's what happened on our previous problem. We saw the parabola intersect the x-axis in two places, we knew that we should have two solutions. all right? The second situation would be if the parabola only crosses the x-axis in one place, like you see in the middle picture. If that happens, you only have one solution. And if you look to the far right of the bottom picture on page 644, if the parabola does not cross the x-axis at all, that would tell you that that particular quadratic would have no solutions to it. So there are three types of situations that can come up when you are solving quadratics. Now, last chapter, whenever we solved, we got solutions. It is possible that in factoring, the equation wouldn't factor and you might not have a solution. That's possible too, okay? We'll get into that more in chapter 10 as we go. Let's do another problem. Let's go to page 647 and let's go to number 9. And it says solve the equation by graphing. So again, we don't even need to show work. All right? We're going to start off by typing the equation in our calculator. You can see I hit the y equals key, then x squared minus 6x plus 9. Okay? Do that first. From there, hit the graph button. When you hit the graph button, do you notice it looks like the parabola is only touching the y-axis I misspoke. It looks like the parabola is touching the x-axis in only one place. Now, it's hard to tell on this calculator. It looks like 1, 2. I'm guessing now. I don't know that for certain. It looks like x might equal 3 here. Let's check by going to a table. So go ahead, hit the second key, and hit the graph key. If you hit those two keys, second graph, you will create a table. And let's take a look at our table. Does our table say 3, 0? Yes, it does. So my solution would be 3, 0. There's only one solution to this problem. In other words, remember, actually, when we factored this, there is two solutions. It's just that they're both the same. If I factor x squared minus 6x plus 9, let me just do that real quick. You might remember this is a perfect square trinomial. It's a perfect square trinomial. And in a perfect square trinomial, remember, x times x is x squared, 3 times 3 is 9, and I'm subtracting. This factors into x minus 3 times x minus 3 equals 0. For this to be 0, I get 3, and for this to be 0, I'm getting 3. So you notice I am getting two solutions. They just happen to be the same. So in reality, I only have one solution. That's what this picture is telling me. Let's do another one. How do I approximate a function to the nearest tenth like they ask us to do in 37 to 45? How do we do it to the nearest tenth? Okay. Follow the same procedure. First of all, go to your y equals key, type in the equation. So in 37, it's x squared plus 4x plus 2. Go ahead and type that in your calculator. Go ahead, hit graph. When you hit graph, you will notice it looks like the parabola is intersecting here and here. So I'm definitely going to have two solutions. But you notice these don't look like they're right on integers. It looks like one solution, like right here, would be between 0 and negative 1. And over here, it looks like I'm between, let me see, 1, 2, 3. Looks like I'm in between negative 3 and negative 4. Okay, so how am I going to figure out what these are to the nearest tenth? Well, what we need to do, first of all, is we need to go to our table. If you go to your table, you'll notice the answers are definitely in between, or the solutions are definitely in between 0 and negative 1 and negative 3 and negative 4 like we predicted. And here's why. Do you see how my y value went from 2 to negative 1? When you go from a positive to a negative, does it make sense you must have passed 0 to go from positive to negative? And what about here when you go to negative to positive? We had to pass 0 here also. So the graph definitely crossed at 0 somewhere in between 0 and negative 1 and negative 3 and negative 4. I can see that on my table. But I need to round these to the tenth, and this table isn't helping me. It's just verifying that I have one response between negative 3 and negative 4, and I have another one between 0 and negative 1. How can I get these to the 10th? Well, what I need to do is I have to change my table. And I know we've talked about this in class earlier in the year, but we need to talk about it again. To change your table setup, you go to second window. I'll highlight the keys here. Maybe I'll do it in yellow. That should show up right. Hit second and then hit the window key, and you'll see this picture. All right, you'll see a screen like this. Remember, the table start says where do you want to start your table at. I would make sure that this is set to 0. If it's not set to 0, just change it to 0. And then this triangle table, that little symbol means interval. Interval, remember, means like, in this case, the interval is 1. We're going from 0 to 1, 1 to 2, or 0 to -1, -1 to -2. We're going by ones. I want to change my table to tenths because I want to round to the tenth. So just go ahead in here and instead of 1, highlight 1 and type in 0.1. All right, go ahead and do that. So you want to type in 0.1. Now, when you do that, go ahead and make another table. And you can arrow on your table until you get between -3 and -4. So let's get between -3 and -4. And now what I want to find is when does this table cross from positives to negatives? And you see right here, the table crosses from positives to negatives. So I know my answer must be -3.5 or -3.4 to the nearest tenth. Look carefully at these two numbers. Which one is the closest one to 0? Well, do you notice that we have 25 hundredths and -4 hundredths? Well, -4 hundredths is certainly closer to 0 than 25 hundredths. So -3.4 would be the closest value for x that would get us to 0 for y. So that's one approximation. -3.4 is one of the solutions or the roots. To find the other one, remember, we got to scroll between 0 and -1. That's where our other solution was. Find out where y goes from negative to positive, and you can see it again right here. And we have the same two numbers again, -0.04 and 25 hundredths. Well, -4 hundredths is definitely closer to 0 than 25 hundredths. So -0.6 would be the second closest approximation. All right? So those are the two solutions for that. So again, maybe I should write these down. It was -3.4 and -0.6 would be my solutions approximately to this was number 37. Okay? Now remember, these are only approximations. Those are not exact results. Okay? When you are done approximating roots to the 10th, you might want to change your calculator table back to how it was. To change your table back to how it was, just go back and hit the second window key again. Let me highlight those. Hit second window, and you'll see the screen. And all you need to do to get your table back to normal is plug in 0 for table start and plug in 1 for table interval, and now your table will be back to normal, okay, the way you want it. Let's do one more, number 38. They want me to approximate the zeros to 38. So let's do one more. So let's go ahead and make sure, if we want to find the zeros of the function, remember we got to plug in 0 for f of x, which I did. Now I'm going to go to my calculator, and you can see up here I typed in x to the second power minus 5x plus 3. And then I went ahead and hit graph, and I see this graph. And you can notice that it looks to me like I have a solution between 0 and 1, and it looks like, let me see, 1, 2, 3, 4. Looks like I got another one in between 4 and 5. So I got to find the solutions to the nearest 10th. So I'm going to go ahead. I already changed my table into the 10th intervals. You can see that I went back and changed it. So now one solution's in between 0 and 1. Do you notice? Here's where we go. Here's where the values go from positive into negatives, which means right in between here we pass 0. Which one of these are closer to 0? Is it 36 hundredths or -1 hundredths? Well, certainly 1 hundredths is closer than 36 hundredths. So 0.7 is one of the roots. The second root's in between 4 and 5, so I arrowed down between 4 and 5, and again I saw right here we're going from the negatives to the positives. 1/100 is closer to 0 than 36/100, so 4.3 is the other root, so it looks like 0.7 and 4.3 are the approximate roots. Okay, those are the approximate roots to number, this is number 38 we said, all right? They're going to ask us, this is always a question people ask each year, there's some surface area challenge problems on page 648. I think it might be good to walk through one. It says, use the surface area of the cylinder to find the radius to the nearest tenth. And I typically ask one of these questions on my chapter quiz each year, all right, or at least something like this. So let's do one of them. Remember, surface area means the combined area of all the sides of the cylinder. So I have three major parts to a cylinder. I got a top, I got a bottom, and I got the side of it. We're like, if this was a soup can, you just write on here. Let's just write a soup can. We got Campbell's soup. Okay. The label, the paper label is called the lateral area. Okay. The top area is a circle and the bottom area is a circle. Okay. Now remember, to find the top area, a circle's area is pi r squared. The bottom is also a circle. It's also pi r squared. And the lateral area, and you can see I can just erase this out now because I have it written here. The lateral area you would find by 2 pi rh. This is something that you should have been taught. You should have been taught this for sure back in 8th grade. Okay? If you don't remember how to get to this, please ask me in class and I will review that with you. Okay, but that's something you should have already learned how to get the lateral area. Okay, so to find the total surface area, let me just write this out. Can you see the total surface area would be taking the top area and the bottom area, adding those together. So when I add those together, let me write out the total surface area of a cylinder formula. It'd be 2 sets of pi r squared, right? Top and bottom, 2 sets, plus you have 2 pi rh. That's the total surface area. So in this problem, in number 47, they told me the total surface area is 251. So that's what I plugged in for total surface area. I have 2 pi r squared, and I have the height is 12. I'm sorry, I misspoke. The height is 6, I meant to say. I'm plugging in a 6 here. If you look at number 47, the height is 6. Well, if you take 6 times 2, you get 12 with pi r left over. All right? Now remember, I'm looking at this, and right away, I know when we look at this, it looks really complicated. But remember, pi is just a number. This is second degree, right? It's a second degree equation, so some bells and whistles ought to be going off in your head. Second degree equation means get everything on one side, 0 on the other. Let's go ahead and type this equation in our calculator now. So I'm going to type it in. 2 pi x squared plus 12 pi x minus 251. Now, in our calculator, radius is just the unknown, so I'm using x for my radius. That's my unknown, so I just typed in x instead of r. Doesn't matter what variable I use. Okay, so I'm going to graph this thing. And when I graph it, you might see a line run down your screen and then a line run up the other end. Okay, and you might be like, what happened? That's not a parabola. Yes, it is. It's just this giant parabola. Let me get a different color. What's happening is this parabola is doing this. It's going down here, way off your screen down here, and coming up this way. It's a parabola like that. Okay? So we have two solutions. We have a solution here, and we have a solution here. Now, first of all, the negative solution we can cross out, because think about it. I can't have a negative radius. That doesn't make any sense. Remember, R stands for radius. Radius is this right here. the distance from middle to the edge. I can't have a negative radius. So I can throw that second solution out. This looks like 1, 2, 3. It looks like it's really close to 4. So let's go to our table. Make sure you round your table to tenths. And you can see I go from negative to positive here. And 0.32 is definitely closer to 0 than negative 8.4. So the closest number to 0 is 4. And remember, they want us to round this to the tenth. It says in the directions, so we should put 4.0. That's actually rounded to the tenth. Okay? I've covered everything I want to cover in my video. I guess there's one more thing I wanted to talk about or just quickly say. This is a great question that people ask. Okay, I always have people say, Mr. Lemansky, using my calculator is so easy. Why did you make us factor in Chapter 9? Okay, why did you make us learn how to factor when we can use our calculator and get all these answers without even having to do all that factoring work? Okay, so why did you make us, let me write this down right, why did you make us learn how to factor? Okay, well, here's the big reason. When you use your calculator, do you notice? Look at these answers and think about them carefully. Was this answer exact? And you should be saying, no, it wasn't. It was approximated. Let's go to our previous question. Was these answers for number 38 exact? And the answer you're coming up with is no, they're approximate. Okay, they've been rounded. All right, let's go back to one more problem. Okay, were these exact? And the answer is no, they're rounded. Okay, so the main reason you need to know how to factor, there will be times when you need to know the exact results of a quadratic. You need to know the definite or the exact, I guess I don't know how else to say it, the exact results. Why did I make you learn how to factor? Because when you factor, you can actually get the two exact results. The calculator method is great if we only need to approximate results, if we don't need exact values. If you need exact values, you're going to have to factor. That's the one way you can guarantee you can get them done right. All right, so factoring is something you definitely want to know how to do. That might be a good thing for me to write down, just make sure, because I could ask that on the audit. The answer to this is, why did you make us learn how to factor to solve quadratics? Let me just add that, to solve quadratics. Okay, because remember, you're probably on this video, you're probably like, wow, this whole calculator deal is great. All right, I don't have to do any work, I can get the answers. Well, remember, the reason is factoring yields exact results. Factoring yields exact results, okay, where the calculator has to round, okay, where the calculator gives rounded results. If I can spell calculator right, that would be great. Okay, well, the calculator is yielding rounded results, okay. So that's important to understand. So again, the calculator's great. I love doing it this way. It's easy, but if I need exact results, I have to be able to factor. All right, I'm going to stop my video here. If you have any questions, we can go over those in class tomorrow.